Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello everybody and welcome to today's episode of the Space Industry Podcast by SatSearch. I'm joined today by Adrien Saada, Operations Officer at Space Sustainability Rating, which is a non-profit based in Lausanne in Switzerland. We're going to talk about a lot of topics related to sustainability and space debris and the various initiatives and things going on in this very important aspect of the industry, something becoming more important every year. So, Adrien, great to have you with us today. Welcome to the podcast. And I wondered if you could just add a little bit to that introduction to the SSR, the Space Sustainability Rating. Just give us a little bit of the background and overview of the organization.
Hello, Hyrule, and thank you very much for having me today. So, yes, the Space Sustainability Rating ID was initiated by the World Economic Forum back in 2019. And after being just an ID, was actually developed by a consortium of organizations, including the European Space Agency Space Debris Office, the MIT Media Lab Space Enabled Research Group, Bryce-Tech, the University of Texas at Austin. And after a period of development of the rating methodology, it was handed over to the EPFL Space Center in Switzerland, in Lausanne, during a time where we basically spun off the project to now become a non-profit organization in Switzerland.
Right, fantastic. That's an interesting history. A lot of stakeholders that are quite well known in the industry being involved. So it's great to see these sort of collaborative approaches being taken to what is essentially a problem that affects multiple different stakeholders at the same time and requires collaboration. You'll talk more about this, I'm sure. I would stay on a collaboration on a scale we haven't yet seen in the industry. So let's dive into this topic today. So the issues of space debris and traffic management have been discussed before on this podcast and on our blog, and they're well known to mission designers and engineers in the industry. But the nature of the problem and the opportunities in the space are changing as year by year, quarter by quarter. So just to set the scene a little bit for our discussion, I wondered if you could give us a quick overview of the current status of debris mitigation efforts today.
Sure. So today there are actually a lot of ways in order to mitigate the risk of space debris, and efforts can be implemented in many different aspects and by different stakeholders. So maybe I'll just start with satellite operators and basically what they can do when they design and operate their mission. So first and foremost, even when a mission is planned, having a management system and planning of space debris mitigation activities is a must. And as part of this, a space debris mitigation plan can be defining the activities during the project development in order to have space debris mitigation requirements defined and also reviewed as part of the mission development, using tools such as compliance matrices in order to be sure that the requirements are met. But also, for instance, when the mission is operated, the review shall continue and in-orbit monitoring shall be done. Of course, there are now many design aspects that comes when you launch an object into space. And of course, it is in the best interest of all satellite operators to have reliable objects up there to be sure that it will not fail. For this, it's also aligned with the goal of any spacecraft operators to have a reliable object in order to be able to carry out the mission until the end and also until the spacecraft is disposed. There are also efforts being done in the direction of making sure that no objects are released or part of the operation. For instance, for Earth observation satellites, can be lens caps or any objects or ejecta from solid rocket motors, for instance. Now there are also a lot that is being done also on collisions, micrometeoroid and orbital debris analysis, study basically the impact resilience of a spacecraft in case there are collisions with small objects or bigger objects. Also, still on collision avoidance, the capabilities that a spacecraft has to be able to maneuver, but also what is the tolerance of the risk up there. So there are some studies that needs to be done with regard to what is the collision probability on a very specific orbital regime where the spacecraft operates. And in case there is collision avoidance maneuvers to be performed, of course, there are processes of coordination in case two active objects needs to be done. So those are efforts in which the community is very active. And in that direction, there is also a lot that needs to be done still on transparency and data sharing, which is basically trying to reach out to other objects in case you have a conjunction alert and being transparent enough to share some orbital data that would be useful for spaceflight safety, such as ephemeridis. Finally, on the end of life, so end of the mission, something that is really important for a mission to implement is passivation. So this is battery depletion, making sure that all the onboard stored energy is depleted, and also the propulsive systems shall be passivated. So this starts to be done on a regular basis for all spacecraft, and it's part of the mitigation effort that needs to be done. Of course, for a smaller spacecraft and CubeSats, sometimes it's a bit harder to get those passivation done. And of course, orbital clearance. So for spacecraft operating in the low Earth orbit, which is very congested, it's also very important that the spacecraft is not interfering with other objects and can be potentially directly deorbited after the end of operations. So those are basically all the efforts or part of the efforts that can be done by a spacecraft operator or a spacecraft manufacturer when designing the mission or designing the subsystems. But there are also other type of stakeholders that actually can help in space debris mitigation efforts. And in there, I think about many companies that are actually offering consultancy in order to defining a strong space debris mitigation plan, so setting up the actions, the requirements, and supporting those efforts that needs to be implemented by operators. But of course, also space situational awareness providers who are actually supporting the operators in having accurate and precise orbital data to support informed decision making when it comes to spacecraft operations and collision avoidance, for instance. Those SSA providers, they also provide tracking of debris, which is very important. You need to know the environment you are operating in. And in the future, there are going to be efforts in tracking smaller objects and more often to be able to take informed decision on what's around you and how you should operate in that environment. And finally, the last part I wanted to also address are the space debris mitigation efforts that are done by regulators and policymakers, because this is also a very important part of the process. And in there, we see actually a lot of change, and I feel the momentum with regard to new regulatory evolutions. So we've seen some FCC updates for end of life. The French Space Operation Act has been updated last year. ESA space debris mitigation requirements have also been updated. And this is also a very important part of the process. ESA has launched this initiative, which is called Zero Debris, in which they have collaboratively developed a charter that all satellite operators or policymakers or researchers, anyone really interested in space debris mitigation can sign, which sets ambitious targets for 2030. And so this part of the spectrum is very important. And this is a bit in that direction that the space sustainability rating is going, since most of those best practices, guidelines, and instruments are actually non-legally binding. The goal of the SSR is really to incentivize the operators to follow those and to follow these best practices and show it to the world that they are putting in place those space debris mitigation efforts.
Fantastic. Thank you. That was a really detailed overview. It's clear that you guys are approaching this problem holistically. And I think, a lot of this ties into this kind of more general industry shift that we're seeing, mission development, professionalizing, which requires you to use the best sources of information, the best service providers that you can afford and that you're able to access in order to create, as you mentioned, mission plans, but also using up-to-date information about the orbital environment, because that's, at the end of the day, this is about protecting and developing an environment for everybody, a literal, physical environment that can be utilized and accessed safely. And you mentioned risk and all these, the technological solutions to reduce the amount of debris that's created in new missions. But to follow up on that, obviously there are plenty of missions that have failed. There are satellites that were dead on arrival or have lost communications. There's debris up there. There's a lot of debris up there. How about active debris removal? We've seen various missions in various stages of development in this area. I wonder if you could give us a few examples in this area and maybe your opinions on how successful some of these technologies could potentially be. This is taking pieces of debris out of orbit that are already there.
Yeah, sure. And I'm not really an expert on active debris removal, though I've been a bit following on what's happening. And of course, when we talk about active debris removal, we think about astroscale, we think about ClearSpace, which is also initially based in Switzerland, and different approaches with collaborative targets or non-collaborative targets. And I think that active debris removal at some point will be needed in case we want the curve of orbital debris to decrease at some point. So if you look at long-term extrapolations of the space environment, that even if we stop launching today, the number of space debris in orbit is going to continue to increase. For sure, for the targets that are actually the most dangerous in terms of risks, then active debris removal makes a lot of sense. Now, there are also many challenges with regard to achieving an active debris removal in terms of pose estimation, navigation, capture, so the contact as well. And even once the object is captured, there's also a lot of challenges on attitude control and telecommunication visibility for capture. I think that this technology will work at some point. For now, we have more or less proof of concepts and demonstrators and missions that are planned. But for now, the market, I would say, is not there yet. And this is why I think there's a need of support from the regulators, which is also what we've seen, right? For instance, ESA is funding the ClearSpace 1 mission from ClearSpace. So there's a need for the regulators to push towards that direction if we want this to happen. And actually, both remediation, so active debris removal, and mitigations are needed. I feel that today, mitigation is the easiest way actually that we could implement. So meaning that trying to encourage spacecraft operators not to generate more debris, but active debris removal will surely be a technology that we'll need in the future. I think it's not there yet, but I'm really looking forward to new developments on active debris removal technologies in the future.
Excellent, thank you. Yeah, I just wanted to ask so that we've got a full picture of the state of play. So that's great. So let me ask a little bit more specifically about your work in Lausanne. So the Space Sustainability Rating, or SSR as we mentioned for short, is an example of a collaborative tool that's been developed to help ensure a more sustainable orbital environment. Could you explain to our listeners a little bit more about how it works today, how it operates?
Sure. So the Space Sustainability Rating is a rating methodology. So it is an evaluation which provides a single score, a single aggregated score for the sustainability level of a space mission, and mostly applied to satellites. So the first question maybe is, why do we need an SSR? I briefly mentioned this, but most of the regulations, so depending on the regulators and the countries in which the spacecraft are launched from, are non-legally binding. And we see that actually, if we continue business as usual, it's going to result in a space environment in which the collision risk is going to continue to increase. So it means more catastrophic collisions, creating more debris, increasing the risk of collision, but also more operational burdens for operators. So even though there is no catastrophic collisions, if we need to do more and more conjunction, if there are more and more conjunction alerts, more and more collision avoidance, there's less time for primary mission to occur. So in that regard, SSR is really useful as an incentive for operators to start to implement the best practices that are identified. And actually, the SSR is not trying to replace those existing instruments that are actually very well built and based on consensus as well, but rather here to incentivize and to give the opportunity to the satellite operators to show that they are doing the effort, but also show it using a third-party assessment, meaning that it's not only the operator saying, we are doing very good, they are going through an evaluation that is performed by someone else. So this provides more credibility to it. Now I'll briefly touch also on how the rating is built, because I think it's quite important as well. The SSR is modular. It's composed at the moment of 6 different modules. And of course, as the regulations will be evolving and best practices also will be updated, then the SSR will be updated accordingly as well. For now, what's inside are one module that is called the mission index, which is basically a space risk footprint. So it's based on collision probability and severity, taking into account the existing populations of existing satellites, active satellites, and debris from a database from ESA that is called MASTER. And it computes the cumulative probability of collision for each object of the mission. So meaning that if there is a constellation, this is the aggregated collision risk for all the spacecraft of the constellation that are accounted for, multiplied by the severity in case a collision occurs. So for this, there's the breakup model in which a catastrophic collision is simulated, and it basically generates a cloud of debris. It's propagated. And then, depending on the number of debris and the increased risk for the space environment and other active satellites, then a score is awarded. So this index that takes into account the collision risk also takes into account the fact that some missions, they can reduce the risk by implementing collision avoidance. So let's say that a spacecraft will maneuver each time there is a conjunction alert of 10 to the minus 6. Then the index is mitigated. So the impact is mitigated by the risk reduction achieved by this collision avoidance. And finally, something that is very important in that index is also the disposal strategy. Because if you operate in LEO and you don't dispose the spacecraft, then the spacecraft will remain in the environment for, let's say, a given period of time, and the aggregated collision probability for this period of time will increase. If you dispose the satellite and the orbital lifetime is shorter, then in that case, of course, the aggregated collision probability is computed over a shorter time frame, and so the collision risk, hence the impact on the environment and impact on other objects, is smaller. This is a new approach that is also based on orbital capacity, so we could have an entire podcast dedicated to this. It was actually derived from a methodology developed by the European Space Agency Space Debris Office. But what is shown with this approach is that if you behave well, if you dispose your satellite, if you do collision avoidance when you are supposed to, you will score well in that module for sure. The other part of the rating are DIT, that stands for Detectability, Identification, and Trackability, which is a module that was co-developed by the MIT Media Lab and the University of Texas at Austin, which basically assess if the spacecraft can be detected by a ground sensor network, so that the spacecraft can be basically cataloged and that everybody knows where the spacecraft is. Trackability as well, to know the orbital evolution of this object. So this is also a computational model. There is then a dimension of collision avoidance processes, meaning what are the processes in place within a company to be able to successfully implement some collision avoidance maneuvers, or is there any contracted SSA provider that is providing this service so that the mission, if there is a conjunction alert, can react. We've also mentioned a bit data sharing and transparency. So something that is very, I would say, weird in space today is that most of the collision alerts, high-risk collision alerts, the coordination is done through a phone call or an email. And because the platform, I would say, not at the moment automated, is starting, but still we need those contact information to be shared of the flight dynamics teams, for instance, or collision avoidance team. And we need to have access to the people that are basically able to do something in case there's a conjunction alert. And of course, the data, precise data, orbital data is needed. This module of SSR asks what type of information you are sharing that would be useful for spaceflight safety and with who you are sharing this information. And operators that would share information with other operators, network of operators such as orbital neighbors, for instance, or to a network of operators, or even to the public, will score in this SSR module. We've also mentioned a bunch of norms, standards, best practices, guidelines on the design of the satellite. And we have one module of SSR, which basically evaluates the compliance level to those existing standards, not to replace them, but really to incentivize operators to follow them. And we've also mentioned active debris removal. One part of the SSR, which is only a bonus score, is dedicated to readiness to be removed in the future, so having some interfaces on the spacecraft so that the spacecraft can be removed. And with this, basically, all the criteria are evaluated into the modules, and then one score per module is issued that we then aggregate into a single score. Based on the score, a spacecraft is then awarded with a label, which can be no label in case the spacecraft fails to score enough, the mission fails to score enough, and then bronze, silver, gold, or platinum.
Fantastic. It makes it all very clear for those outside, but obviously a complex undertaking to understand all those factors, to weigh them accordingly. And as you mentioned, you're dealing with not just technical factors and regulatory compliance, etc., but the human elements of this potentially competing organizations being willing to share the right data with, as you say, their orbital neighbors, and to do so by accessing the people who can do something about it is a business challenge as well as a people challenge, as well as a technical challenge. We've heard stories of OneWeb and Starlink and not sharing information in ways that we would find difficult if these were two airplanes, right, who were close to each other. That's fascinating. Thank you for going into all that detail about the SSR. As you mentioned, the development of the modules and the rating moving forwards is going to be partially defined by what comes down from a regulatory standpoint, although, as you mentioned, a lot of these things are legally non-binding. So there's an element of unpredictability there, but it does seem like you're plugged into all the ESA and the NASA and the regulatory bodies that will hand these things down. But I wondered what is next for the SSR. How do you think the system can help mission designers moving forwards or building those missions for tomorrow, for next year, for 2 years' time?
Yeah, so I think the SSR has definitely a lot of value in helping mission designers to demonstrate compliance and demonstrate the efforts they are doing towards space sustainability and space debris mitigation. One of the strengths of the SSR is something that we mentioned before, the fact that the evaluation is performed by a third party. So this is actually helping mission designers to show that they are not only showcasing efforts that they are doing, and they are going through a third party analysis and evaluation, which is, I would say, more transparent. The SSR methodology is also very transparent. So if you go on the website, you will see what the modules are made of. There are academic papers showing this. So it's an effort in the right direction for mission designers to show that they comply with those standards. Something that is really also useful for operators and mission designers is the fact that TSSR is not only the evaluation, it's also about providing some recommendations. Once a rating has been issued, we also provide recommendations based on the analysis of the score that was achieved by a given mission. As part of the rating process, it's not only data that is provided by the operators and then we provide a label. It's also a recomputation loop in case some improvements have been identified by SSR and that the spacecraft operator is willing to implement those recommendations. And with this, of course, if the SSR is applied early on in the design, there is more flexibility to implement things, for instance, on the design of the satellites. But even if the spacecraft is already launched, there are some data sharing practices or operational practices that still can be changed, and in which the SSR can have a value in providing recommendations. Finally, at the moment, this is, I hope for tomorrow that the SSR will allow this, but I think that when you do a sustainability assessment, it can really support in attracting investors, facilitating procurement. So this is really something that we are trying to pushing towards for SSR, is to be able to create value for the companies so that they can show their sustainability efforts and actually get something out of it. Because it's not only about doing some efforts, it's also about financial sustainability. It's also about having a business model that works. Finally, I think there's something that is really important with SSR is that we are up to date with the regulations, and we are going to conferences and we know what the updates are going to be like. So a company that is going through a space sustainability rating can also anticipate some of the regulatory changes. So it's better to move now and do the efforts now rather than implementing big changes when the regulations come. And we've seen that actually the regulations they are going to change, and we've seen that in Europe, in the US. So it's really moving forward. I would say that next for SSR, there are several things that we are going to do. One of those important things is to identify policy options for SSR. So we've been asked by actually many operators and stakeholders, is the SSR going to be part of licensing? And I think this is something that is really interesting. So for now, it's an incentive for operators to follow this. But at some point, and I expect that some indicators will be part of licensing, and I hope it's going to be the case. It could be SSR, it could be something that is actually developed by each regulator. But in any case, it has been identified, and also in this zero debris charter that was written, that some performance indicators needs to be developed and implemented. So that's one of the things that SSR shall be doing. There's also a part on the certification. So for now, SSR is just a labeling system with a rating scheme, but we want to move toward a real certification scheme so that it gives more credibility and more value also for the rated operators. And of course, I mentioned that regulations are going to change fast. So I think that SSR shall also reflect the highest standards for sustainability and I would say best practices. So the SSR needs to be flexible and updated. And so that's also part of the plan for next steps for SSR.
Brilliant. Thank you. Great to hear about the plans of the organisation moving forwards, and best of luck with all of that work, all the things that you mentioned. I think all of these initiatives are so important in the industry for many reasons, and are increasingly being appreciated as such definitely by those in the industry. And as you mentioned, where finance and investors, etc., are concerned, and the end users and the other side, and understanding that you're contributing in whatever way, buying or investing in a business that is taking the sustainability of the orbital environment seriously is really valuable. So thank you for that. So finally, I think I've asked everything I wanted to ask about your work and the SSR. So I just wondered if we could take a bit of a step back and look more broadly at the situation of sustainability, situational awareness, traffic management, this whole area in 2024. And I wondered if there's anything in particular that you're looking out for this year, any good or bad, any specific missions, any regulatory steps forward? Is there anything that you're expecting, or maybe a longer horizon, the next couple of years potentially? Is there any major changes that maybe the suppliers listening out there might have to think about?
Yeah, so I think following the trend that the trend of the past few years, there's going to be more launches, and it's good for the space sector. Let's not deny it. There are incredible opportunities for the space sector right now. I'm slightly concerned for the years to come about the number of different satellite constellations, and I think I'm not the only one. And also with regard to the different satellite constellations serving kind of similar purposes. So meaning that each country or each private actor would have a slightly different service, but serving the same purpose. And that the number of objects that are launched into space for providing those services, I think it's going to be very high. And so in that regard, we've seen it actually with some analysis of the number of conjunction that happened in 2023 as well. We saw some exponential trend in the number of conjunction and collision avoidance maneuvers performed. And so with this, I think that it's very important that we also remember that when you want to be more sustainable, you need to think about in terms of sobriety, and that it has a cost to have more and more objects in space, not only in terms of direct cost of having catastrophic collision, but also in terms of performing those collision avoidance and losing some primary mission time. So I think that for the bad, we can expect more and more object launch and more potentially collision avoidance maneuvers, but also potentially collisions. And so I think that this trend is going to continue, which is something I'm not looking forward to, but I think will happen. Now, on the other side of the spectrum, and things that are actually good, in my opinion, is that we see that the sector is actually trying its best. So it's not only about shaming people and saying, oh, we are launching so many objects and it's not sustainable. We see actually that even those constellation operators, they are doing a lot of efforts into trying to be transparent. So discussing with the communities, and on this, I also want to mention, for instance, Starlink that is talking a lot with astronomers. So it's not about space debris mitigation, but it's talking to communities with regard to impact that are caused by some of their systems. So I think that the community at large is doing some efforts, and that it's going to be backed up by some regulatory changes. These changes in regulation. So we've seen in 2023 the first fine for a spacecraft that was not disposed, and maybe the amount of the fine is not really relevant, but what's relevant is the fact that things are moving forward, and we see regulations being a bit more stringent with regard to what can be considered as operations that are not sustainable. And so with SSR, I think that those regulatory changes are going to help us in actually updating our rating methodology, of course, and having, let's say, new criteria, but also show the importance that acting sustainably is important. So I think that in that regard, in the coming years, we shall still raise awareness, of course, but the space sector is going to change and, in my opinion, comply more and more with space debris mitigation guidelines and best practices and norms. So for this, I'm really looking forward to the next years and see how it changes.
Fantastic. Thank you. I think that's a great place to wrap up. I'm in agreement with you. I think these things are being either driven top down and companies are going to have to comply, and or hopefully they all see the value of complying. And increasingly the conversations that we have with multiple suppliers and mission designers all over the world on a regular basis, you see these issues being taken very seriously. Yeah, and I think the work that you guys are doing to aggregate and understand all this information and actually map it into something that is usable in terms of the rating and the scoring system is really valuable. So best of luck with everything moving forwards.
Thank you so much.
Thank you, Adrien. And to all our listeners out there, thank you very much for spending time with us today on the Space Industry Podcast. We will share some details about the space sustainability rating and the work of the organization in the show notes and in the blog post that will be associated with this podcast episode. And yeah, we'd like to say thank you again to Adrien, and thank you to all of you for listening. And we'll be back soon with another episode of the Space Industry Podcast. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.